Hey everybody, my goal today is to give you a tutorial in less than 10 minutes, walk you through the code of how to build a Tetris-like game. And we're going to use the arcade library, which is a great library for 2D games in Python. And we're going to do all the rest of it from scratch, and it's not actually going to be that much code. I think you're going to be surprised. I assume most of you know how to play Tetris. I'm playing our version of it called Falling Blocks here right now. And you can see we have some controls going left and right, rotating the pieces. We have, some statistics. How many lines have we done? What's our score? I'll try to get at least one line before we move on to the actual code. Okay, let me put this one over here on the right. Let's get one more good. Here we go. We can get a line with this. So just so you see how it works, right? And I assume you know how Tetris works. But anyway, all right, let's dive into the code. So I'm going to start here in my utility module. I just defined some simple utilities here. One is an enum called cell. And Tetris is really just a giant grid. You have a grid of possible places where pieces can be, where the pieces that have already fallen are, and they can either be open, so new pieces can go to those locations, or they can be blocked. So that's what our enum is. Either our cell can be empty or blocked, and that's for all the different locations on the grid. And we also have a way of representing those locations, a data class here called location, and it just has a row and a column. So at each location on the grid, which we're going to be able to find using the location class, we have a cell that's either blocked or empty. Okay, let's get into pieces. So, in Tetris, you have all those, I think it's like 6 different kinds of pieces. And some people call the giant line, for example, the I piece, right? And it can either be horizontal. You see here's a bunch of 4 block cells horizontally, or it can be vertical, right? And you also have the single block piece, right? And it can only be just the 2x2 by itself. You can't rotate it because it would just be the same thing again. And you'll see for each of these, I have what are called positions. I'm calling that like a configuration of the shape and how it can be rotated. So when you rotate it, how does the shape change? Each of those different ways that it can look, that it can be configured, I call each of those a position. And so the I piece has 2 positions. The what we're calling here the O piece only has 1 position. This thing that kind of sort of looks like a J piece when it's upright, let's look at the J over here, that has 4 positions. And then you have the same for the L, for the S, for the T. And I'm defining those positions as a list of lists of that enum cell. So it's a list of cells. And you might wonder, where's the E and the B coming from? Let me go to the top of this file. They're just conveniences. I define the E as cell.empty, the B as cell.block, and I also defined the entire list of cells as what I'm calling a position. So each of our shapes, the S, the J, the T, etc., they can be in multiple different positions. Each of those positions is a list of cells, defining where the empty blocks are and where the blocked blocks are. And by the way, all this code I'm going to link to just below the video on a GitHub repository that you can go and check out in more depth. Again, I'm just doing a quick walkthrough here. Let's see if we can keep to our 10 minutes. So what is a piece? A piece is something that has those various different positions. What are the different configurations it can be in, and what cells are in what places, which ones are blocked, which ones are empty, when it's in those different configurations. Each piece has a different color it can be. It has a location on the wider grid, right? Where on the grid is it? And it has a way of rotating to the right, that's turning to the right, has a way of rotating to the left, has a way of moving right, has a way of moving left. Trivial stuff so far, right? Moving down, moving up, that all makes sense, right? We're just manipulating the location. We're just switching from one position to another position, one way of it being turned to another way of it being turned. That all makes sense. So does properties like color and position, right? They're just returning some of our instance variables. This one's slightly trickier, but not very tricky. Grid location. What do? We go through each of the different items in the configuration, each of the things in the position. So each of those blocked cells for the piece. And we add to it, basically its location. We add to its location. What is the location of the piece? Let's add to it from that inner grid, right? So if I'm currently at location, let's say 5, 5, and I'm looking here, right, at this I piece down here. Well, this B is at location row 2, column 0, right? So I add that 0 and that 2 to the 5, 5, and I'll find something that's at row 7, column 5, right? And then there's also another location that's blocked over here at, one column to the right, so column 6, row 7. So that's what's going on here in these loops. I'm basically just taking the current location of the piece and adding that to each of the individual blocked cells that represents the piece to find where are the actual locations on the entire grid. And I'm returning that as a list of all those locations on the grid. So where on the bigger grid is this piece currently taking up? And this last one here, random, all that static method, all it does is give me a new piece. How am I going to figure out what the next piece is? I just generate a new random one by choosing a random one out of all my different predefined pieces, right? And I have it's actually 7, I said 6 before, right? My 7 predefined types of pieces. And then the rest of this file, as we looked at earlier, is just those predefined different types of pieces. Okay, believe it or not, that's most of the most important mechanics. Defining the pieces is like a lot of the problem. Now let's go to my main module, falling blocks. And a lot of this is just set up for the drawing, but I will go through it piece by piece. Okay, I have a bunch of constants here. How big is the window? What color is it? How many rows and columns does it have? How big are the cells? What are the colors of the cells? Where do we actually start pieces from on the grid? What are the scores we get when we get different numbers of lines? If we get 1 line in a row, we get a different number of points than if we got 4 lines in a row, right? And then how many lines does it take to move from one level to the next? What does my constructor do? It sets up all the basics, sets up the library a little bit, gets my grid. What's my grid? My grid is just a bunch of cells. And most of them at the beginning, actually all of them at the beginning, right, are empty. They're empty cells at the beginning. So it's just a grid of empty cells at the beginning. And the cells, again, are just that enum we looked at earlier, the same enum that the pieces are using. We set up what the next piece is going to be by starting with a random piece. Then we go to this generate pieces method. And what does it do? It takes the next piece and makes it the current piece and then creates, again, a randomly generated next piece. And we're going to end up calling generate pieces every time one piece makes it to the bottom of the screen, right? Some statistics we set up, that's self-explanatory. And then this is a method in the arcade library that says, when do we want to do our updates? Well, we're saying we want to do our updates in some formula that's dependent on what level we are. Why do we need that? Because we want the game to speed up and get harder as we progress from one level to the next. Okay, so every time arcade is going to call down, we're going to basically move all the pieces, the current piece down, and we're going to see if we get to the end of the grid. And we'll come to that actually right now, and I'll come back to the draw stuff later. So what does it mean to go down? Okay, so we're going to try moving the piece down. When we try moving the current piece down, we have to check, is this still a valid position? It could be invalid, right? What if we went off the side or off the bottom? We can't do that. Or what if we crashed into some other pieces that have already gone down, right? So that's what this invalid method checks. It checks, hey, did you go too far to the left, too far to the right? Did you go too far down, too far up? I don't think it's possible to go too far up. And if you did, that's not a valid position anymore. And so we're going to let the caller basically know that by returning, hey, that's invalid. Okay, there's something, or maybe there's something already there. There's something already where that piece is trying to go. Otherwise, it's not invalid. And that means that we can keep playing in the mechanism that we were using. And we're going to use this both for going down and also for trying to move pieces left and right, and also for trying to rotate them. If any of those things cause the position to be invalid, we're going to undo what we just tried to do or go on to the next piece. And that's what's happening here. If it was invalid as we were moving down, okay, you can't move down, so let's undo that. Let's move that piece back up. And that means we've actually gotten to the bottom. That's what it means if a piece is going down and it can't go any further. So what we're going to do is we're going to fill in where that piece is right now as block cells. And we're basically freezing that piece in place. Then we generate the next pieces. We check generating the next pieces. Did we actually generate an invalid position? That means if we got all the pieces all the way to the top and we're generating a new piece at our start location and we can't actually put it in place because we have some block cells that it's hitting, that means the game's over. And we're just going to unschedule and say the game's over. Otherwise, if we did actually move a piece successfully down and then stop it because it was invalid, we need to check if there were any lines. How do we do that? We go through all the rows that the piece could have possibly touched, and we see, are they complete rows from left to right? And the clever way we do that right here is we use the all function that's built into Python to see, are all the cells on some particular row blocked? Are they all block cells? If they are, that's one of the rows we want to remove. And then we go through and we actually just delete from the grid those rows that had fully blocked cells, and then we add in to the end of the grid another row of empty cells. Kind of a slightly clever way of doing it. It's a nice way of being able to remove the whole thing and put a new one in just 2 lines of code. And if we've cleared a certain number of lines, right, we move up to the next level. And anytime we clear any lines, we also increase the score. And if we move up to the next level, we have to actually unschedule through Arcade our down method and then reschedule it at the new faster pace for the new level. Okay, so that is down, that is check lines. That we also looked at invalid. There's not a lot left, believe it or not, that's most of it. Okay, now all we have to look at is drawing and basically handling the keyboard. So let's look at those last pieces. Drawing, what are we drawing? We're basically just drawing a ton of rectangles. That's what the grid is. Everywhere there's a block cell, if it's a particular piece with a color, we draw it that way. If it's just a general block cell from an old piece that had already moved to the bottom, we just have the same color that we use for all of them. And we don't forget also to draw a bunch of those statistics that you see on the right-hand side. I'll go back to the app, right? Drawing this stuff on the right-hand side, there's built-in methods in Arcade for drawing those easily, and we're just using those built-in methods for drawing all that text and drawing our basically our statistics. Okay, simple stuff, built-in methods for drawing text, stuff like that. All that's left is basically handling keys. And what do we do when we handle keys? Well, we're allowing the player to either use the A key for left or the left arrow for left, D or right, etc., right? And what we do is we try moving the pieces, or we try rotating the pieces, depending on what key was pressed, right? And when we try moving the pieces or rotating them, we reuse that same invalid method that we were using earlier for moving pieces down. And if we are invalid, we just undo the move we did. If we tried moving to the right and that was invalid, we move to the left. If we tried rotating to the left and that was invalid, we just rotate back to the right. And then we just have a special one here for space, because if we hit space, we want the piece to instantly go to the bottom. So this is maybe not the best code here. This one little bit here, we have a loop that just keeps moving to the bottom until we can't go any further. And then we say, okay, if we got to the bottom, it must be invalid. So we stop there and move up and break. So this was maybe the only bit of the code that I'm kind of like, I could have written this a little better. Okay, that's it, believe it or not. That's our whole tutorial on writing a Tetris-like game in Python using the Arcade library. Now, I wrote this code years ago. It's linked to below the video. And I actually discovered after I wrote it that they actually had an example Tetris game in the Arcade library's like samples. I think mine is pretty readable. I'm sure theirs is pretty good too. I haven't looked at theirs in depth, but hopefully mine helps you. And I hope that you like these kind of videos where I go through it in a really, really short amount of time, do a quick code walkthrough, don't like linger on all the different individual statements. You can go and read them yourself in the GitHub repository. Let me know in the comments. If you do, I'll do more of these kind of short form Python tutorials or other programming languages too. Hope you have a wonderful day. Thanks for listening. Don't forget to subscribe.